Good day, everyone. It's Manda. Please subscribe to our channel. Uh, Today, our topic we will focus on hydraulics. It's hydraulics through tapered pipe, whereby if you look into our sketch, we will have our pipe whereby we have diameter 1, which is the smaller diameter, diameter 2, though we can still have the water that is moving from this side, or we can have the water that is moving from the other side. So what we do, we take our pipe and then we're going to use the pressure gauges, whereby we're going to have pressure gauge number 1, as you can see. We also we're gonna have pressure gauge number 2 there, whereby we have what we refer to as Bernoulli's theorem. Bernoulli's theorem. We normally use Bernoulli's theorem. Bernoulli's theorem. So Bernoulli's theorem states that the pressure in equals to total energy in is equals to total energy out. So I will simply say total energy in is equal to total energy out. Therefore, what you normally do, good people, obviously when water flows through the pipe and we want to maybe calculate the pressure, there will be what? There will be the velocity. Water will flow with a certain velocity or speed in meters per second. Pressure is always in pascals, good people. And we also have the diameters, it's always in millimeters from our syllabus, millimeters. Therefore, what we normally do, when there is a velocity of water, we're going to have a velocity out as well, here in meters per second. Now, when water is moving, we will experience, we will say it's volume per time, or should I say a flow of rate, which is referred to as Q. So we can have Q1, we say Q1 equals to Q2, which is measured in meter cubed per second. It's flow of water per time, I'll simply say. Volume of water per given time, because of, we can experience volume because of the shape of the pipe, right? Hence we said Bernoulli's theorem states that total energy equals to total energy out, whereby we refer to in and out. Now, Bernoulli's theorem, that's where we're going to look into pressure energy. The formulas were derived from pressure, which means pressure is equals to force over area. But now if we want to go further so that you can have our normal formula, whereby when we calculate pressure through water, we end up saying, where we see force, we all know force is equals to mass over gravity. We say divide by area, which is equals to, where we see mass, we must just remember that volume, density is equals to volume over, density equals to mass over volume. It's given in kilograms per meter cubed, whereby what is happening here is that where we see mass, good people, we make it the substitute formula, which will be density multiplied by volume. So we are going to say, where we see our mass, it's density multiplied by volume, multiplied by our G, divided by area, though we say density multiplied. Where we see our volume, we say volume is equals to area multiplied by the distance, whereby volume equals to area multiplied by distance. We can say distance, which can be S or H, it's up to us, distance. Therefore, volume, we see volume is area multiplied by distance multiplied by G divided by area. So area will cancel area, therefore we'll say pressure is equals to density G S, whereby this S is from here, Then we can say density multiplied by G multiplied where we see S, it's the same as H, which is our distance. So we have this formula which represent pressure through the water, good people, whereby density is always 100 equals to 1000 kilograms per meter cubed, and G is always constant, which will be equals to 9.8. From our syllabus we include one, G equals to meters per second squared. Right, we're going to look into kinetic energy. EK, we say it's equals to 1 over 2 mv squared. Therefore, we also have V represent the velocity. We also look into potential energy. Potential energy, it's equals to mgh. Now we look into these formulas, good people. We look into these formulas whereby we experience pressure energy, we experience kinetic energy, we also experience potential energy this side. Now, potential energy, it's energy due to the position, which is the inlet, and then kinetic